In a random sample of 344 people that were tested for the Norcovirus, it was found that 286 did not have the virus. Construct a 94% confidence interval to estimate the proportion of the population that does not have the Norcovirus. Which parameter are you estimating? So the parameters that we have are the mean of a sample, the mean of a population, the standard deviation of a population, the proportion of a population. These are the types of parameters that we have available to us thus far in the course. So the parameter that we're estimating is a proportion. So it's going to be, since we're talking about a parameter, parameters are related to populations. So therefore, we're looking for a population parameter P. So what is the point estimate? Well, the point estimate that we use to estimate the value of the parameter P is P hat. Okay. Now I'll check all of the requirements that are satisfied. Okay, so when we do a sample, we need to make sure we have a random sample. So we do have a random sample here. It was told to us that we have a random sample of 344 people. The X bar, which is the mean, the X bar distribution is normal since n is greater than or equal to 30. Well, the sample size is greater than or equal to 30. It's 344, but we're not estimating a mean here, so that doesn't really apply in this case. Same for the next one. The X bar distribution is normal because the X distribution is normal. That's not really applying because we're not really dealing with the mean in this case. The P hat distribution is normal since n times P is greater than or equal to 10, and n times Q is greater than or equal to 10. Now, I've seen different bounds for these, but these basically ensure that the P hat distribution is well approximated by a normal distribution given these conditions. So I've seen them as n times P is greater than or equal to 5, and n times Q is greater than or equal to 5. Or n times P times Q is greater than or equal to 10. Whatever it is, that's fine, as long as these conditions are met. So the sample size is 344. The probability of success is, well, we have 286 people that don't have the virus. We're going to do a little calculation here. So let's see here. 286 do not have the virus, so out of 344. So that's 0.83, we'll say. And then 344 times the complement of that, which would be 0.17. Both of those need to be larger than 10. So let's take a look. So 0.83 times 344. Whoops. Well, okay, so I missed a 4 there, but certainly that's still going to be bigger than 10. So I'm not going to change that. All right, then 344 times 0.17. That is 58, so that's certainly larger than 10 as well. Okay, so that condition is met. Which calculator function should you use? All right, now if we're doing a confidence interval, then that means we would either have one prop z interval, or there's another one which is t interval, and finally a third one which is z interval. But t interval and z interval both are related to the mean of a distribution, so that's not applying here. So one prop z end is what we would use in this case. All right, find the margin of error. Round your answer to 2 decimal places. Well, to find the margin of error, we have to use the formula z sub c times the square root of p hat times q hat divided by n. And we have most of these data values, but we don't have z sub c, which is a critical value based off of our level of confidence. To get a critical value based off of your level of confidence, we use the formula absolute value of inverse norm 1 minus the level of confidence divided by 2. So to get this, in this case, I would take 1 minus the level of confidence that is requested to use here, and I need to go back up and see what that is. So we want a 94% confidence interval, so that's what we need in this case. So 1 minus 0.94 divided by 2, and that's 0.03. Okay, and now I need to take inverse norm of that. So second distributions come down to inverse norm. And the area to the left is 0.03. That's what we just calculated. And I'm using a standard normal distribution, so leave the mean and sigma as 0 and 1. If you're not seeing this menu here, that's fine. Then just type in 0.03 as the input to inverse norm. You'll get the same result in the end. We do need to take the absolute value, and we've got 1.88. So this is 1.88. All right, so this is 1.88 times the square root p hat. So that is the probability of success. So we're setting success as someone does not have the Norcovirus out of the population. And so that means this value right here is the proportion out of my sample that does not have it. So that was 0.83. And then the probability that someone did have it, that would be the complement of that, which is q hat, or 0.17. And then we had 344 in our sample size. Let's take a look at what our margin of error is here. All right, so 1.88 times the square root of 0.83 times 0.17 divided by 344. That gives me 0.038. And that's one way I could certainly go about that. Another way is to actually just use the formula that's in the calculator. So if I go over to the tests menu, so stat and tests, and come down to 1 prop z interval. So I'm doing a confidence interval, so I need 1 prop z interval. All right, so x, this is the number of items that favor the event out of the sample, which, going back to the problem here, that was 286. N is the number of people in the sample total, so 344. Level of confidence is 0.94. If I hit calculate, that gives me the endpoints of my interval. So I could actually come up with the margin of error from that. But what I would need to do is take 0.869 minus 0.793. All right, so 0.869 minus 0.793. And then divide that by 2. Whoops, not multiply. Divide it by 2. And so that's another way of getting that margin of error strictly from the calculator. And you'll see it agrees 0.038. All right, the confidence interval, you can get the calculator to come up with a confidence interval for you. That's perfectly fine. What we had were the endpoints 0.793 and 0.869. Or if you already have the margin of error, then the confidence interval comes from taking your point estimate plus or minus that margin of error. So the point estimate here was 0.83. If I subtract 0.038, and then I add 0.038, that's another way of coming up with the endpoints of those intervals. And there's a little bit of rounding error here, and the site generally takes that into consideration when accepting answers, because there can always be a little bit of rounding error. All right, so there's a confidence interval. Select the correct conclusion. We are 94% confident that the proportion of people in the sample that tested positive for the Norcovirus is between the two proportions found. Okay, well, that sounds okay. Let's read the rest of them. We are 94% confident that the proportion of people in the sample that tested negative for the Norcovirus is between the two proportions found. All right, the difference there is one of them said tested positive and the other one said tested negative, so let's keep that in mind. All right, let's read the rest of them. We are 94% confident that the proportion of the population that have the Norcovirus is between the two proportions found. And we are 94% confident that the proportion of the population that does not have the Norcovirus is between the two proportions found. All right, so the differences here, we have people that have this virus versus do not have the virus out of the population. But that's the differences here. This is A and B. This is out of the sample. And C and D are out of the population. So what we're doing with a confidence interval is we are taking our results of a sample and extending those results to the entire population. So that removes A and B as possibilities for this result here, because the final interpretation is going to have something to do with the population of values. Now, whether it's folks that have the Norcovirus or does not have the Norcovirus, we just kind of have to go back to what we said originally right back up here. We're estimating the proportion of the population that does not have it. So that means this one is out. And so our final interpretation would be this right here, that we are 94% confident that the proportion of the population that does not have the Norcovirus is between the two proportions found.